Today we're going to go over how to simplify radical expressions. And um, here we're going to start working with learning target 10.1, which says that I can simplify radical expressions. And radical expressions are not the easiest of things to understand, but with a little practice I bet that you could figure out how to understand them. So over here we have a few radical expressions and a few examples that we're going to go over. So let's start with this one. The square root of AB. So basically the square root, it's a square root because it doesn't have anything inside this little area right here. So when it's blank and there's nothing, it's a square root. You're looking for pairs of 2. So the square root of AB is basically saying the square root of A times the square root of B. And then the same thing when you're dividing. You have the square root of A divided by B is the same thing as saying the square root of A divided by the square root of B. So let's take it with a problem here. The square root of 36, well, that's a perfect square. A perfect square is two numbers that are the same, that when you multiply them, they become one number. So that's like 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 9 times 9, 81, and so on and so forth. That is a perfect square. So like if we were to square 49, it would be 7, because 7 times 7 is 49. Perfect square. But what happens when we don't have a perfect square? Then what do we do? Well, let's look here. We have the square root of 72 equals the square root of 9 times the square root of 8, because 72 is not in fact a perfect square. So here, because like I said, it's a square root, we're looking for the pairs of 2, okay? We're looking for those pairs of 2. So we could break this down even further. We could break this down even further. 9 is a perfect square, 3 times 3, so that's what we have right here. 8, also a perfect square. What? No, sorry, it's not. It's not a perfect square. My mistake. It's 2 times 2 times 2. Those are the factors. So what we're going to do is we're going to take the 3, since there's 2 3's, and 1 2, and we're going to multiply them. And that's going to give us 6. So we're going to put the 6 on the outside. So basically, that's going to get rid of them, and that's going to get rid of them. So basically, they don't exist anymore because they're right here. They exist, but they're just in a different form. So what's left? Well, we only have this 1 2. Oh, that was a bad arrow. But we only have this 1 2 left. So we're going to put that inside. So you're probably wondering, Angelo, why you said that there were other forms? You said that there were other forms, not just square root. Of course there are. There's a cube root when there's a 3 right here. And then there's a fourth root when there's a 4 right there. So when you have a cube root, you're looking for the pairs of 3 that you're going to put on the outside. Looking for pairs of 3. When you have a fourth root, you're looking for the pairs of 4 on the outside. And so on and so forth. So I hope you understand now how to simplify radical expressions. And we'll go over the other 2 learning targets for Chapter 10. And then we'll be done with Chapter 10.